Oh, what's up guys, my name is Nishit Tarantula. So, in this video we will be talking about something really interesting. We will talk about the true nature of light, that whether light is a particle or a wave. So to understand this, let's first move on to the late 1600s in England. There was a prominent scientist, he was a prominent mathematician and a prominent theoretical physicist. Yeah, you're right. He was Sir Isaac Newton. So when Sir Isaac Newton looked after the reflection of light, that is, suppose this is a screen, you can say, and when light from the first medium falls in the second medium and gets reflected by an angle back to the first medium, that's the reflection of light. So Isaac Newton thought that if light can get reflected because of some obstruction, light should be a particle, not a wave, because this pen is a particle. If I just throw this pen on my hands, this pen, instead of moving further, this pen just bounced back to my lap. So that was the same idea. So this was the same idea of Sir Isaac Newton. He thought that light is made up of particles. Then came the double-slit experiment, Young's double-slit experiment. He conducted that experiment to determine that whether light is a particle or a wave. I've made a video on wave-particle duality. On the double-slit experiment with Aryan Kira. We had a great meet, so you can watch that video to understand the double-slit experiment. Let me just give you a brief idea about that. So there were two slits from where light could be able to pass, and in front of those slits there was a screen so that you could be able to detect light. Yeah. So if I say you that what would be the observation if you passed light from two slits? 1 minute. Oh, so cool. So imagine these two slits. You can see the distance between both the slits is r. So Thomas Young did the same. He took two slits, and behind those two slits, or you can say in front of those two slits, he kept a detector, or you can say a screen, on which you would be able to detect those lights, you can say. So when light was passed from both the slits, you would say that you would find a stripe of light here and one here. But the observation was not so. Instead, it was found that there were stripes of light in this manner. At the center there was a light of high intensity, and as we move towards the lighter left, we will find that there were more, you can say, stripes of light with less intensity, you can say, but there were more stripes of light instead too. Please appreciate, I don't have great budget, so anyways. So this made Thomas Young think that light is made up of a wave. But first question, that why he observed such pattern. So the reason is, if we imagine light as a wave, so imagine it's light, and from this, you can see, from this slit, when light gets passed, then those waves come out from both two slits which basically looks like two different waves, and when they come out and get bigger and bigger, they overlap each other, something like this. I said that I don't have great budget, so anyways. So they make some interference patterns, and that's the sort of reason which made such weird patterns. So this was a problem. According to Newton, light was a wave and According to Newton, light was a particle, and according to Thomas Young, light was a wave. So what's the true nature of light? Then came Professor Einstein in 1907, and he provided us with his photoelectric effect. It basically says that, where is my pen? 1 minute. So the photoelectric effect basically says that when you bombard some photons, which are basically the energy packets of light, on a surface, then that photon will will displace some electrons from that surface, and those electrons will bounce back, making an angle, and those electrons will be known as photoelectrons. And I've already made a brief video on the photoelectric effect along with its mathematical formulation, so you can check it out, and all the links are provided to you in the description. So Einstein, in his photoelectric effect, gave an idea that light can be both particle and a wave. But this thing required some more, more brief definition. So in 1924, there came a genius. He was Louis de Broglie. So he provided his theory, the wave-particle duality. And according to that theory, every matter in the universe possess a nature of particle along with nature of wave. And that was the idea of Louis de Broglie, and he derived an equation which we know as the de Broglie wave equation, and that is lambda is equals to h by p, where lambda is the de Broglie wave, h is the Planck constant, and p is the momentum. So this equation can tell you the momentum of a photon, that photons also have momentum, and I've also made a brief video on the derivation of this equation, link in the description box. Let's move on. So if the wavelength is equals to Planck constant divided by the momentum, where momentum is classically the mass times the velocity, you can conclude that mass is inversely proportional to the wavelength. Therefore, the greater the mass, the lower the wavelength, or the lower the wave nature. Or also you can say that velocity is also inversely proportional to the wavelength, so you can easily say that the faster anything is moving, the slower its wavelength is. And it says that, and his theory also suggests that when a matter travels at the speed of light, it have a nature of a wave. But particles which are just so slow, like this one, have nature of matter. And that's with the Louis de Broglie hypothesis, but this is now known as the Louis de Broglie theory, or de Broglie theory, because it's now proven, provides you with a nice idea or a nice definition of light and every matter in the universe, that every matter, even light, have both particle and a wave nature. Thank you. Bye.